Okay, so your basic question is how do you go about simplifying the roots? So for the example that they have here, it was a negative and a 27. Um, when you're working on trying to simplify a root, there are a very limited number of numbers that will help. They are 2 squared would make 4, 3 squared would make 9, 4 squared would be 16. I'll stop soon, 5 squared is 25, right, and on and on and on. So we're looking for perfect squares. These are the only numbers that if you run into them, you can actually reduce from under a root. You know, like for instance, if I have the square root of 49, that's 7, because 7 times 7 makes 49. Or the square root of 7 squared, the root undoes the square, that makes 7. So what we're looking for is things that do this. That's our goal. So with that idea, let me do 3 or 4 examples of this, because it's something that generally people don't, it's a little bit hard to get it. Once you get it, it's not that hard, but it's one it's tough to get your head around at first. So I'm just going to do a bunch of them, and hopefully that will click in. And this one is actually not the best one to start with, so I'm going to do something different. Let's do square root 12. So if I look at square root 12, one more thing before I do square root 12. If I have the square root of a times b, if it is helpful, I can think of that as the square root of a times the square root of b. And likewise, if I have this, I can rewrite it as this if it's helpful. So what we're going to do on all these examples I'm going to do is I'm looking at this as something like that, and I want to figure out how I can rewrite it in a way that I can simplify something. And the only way I can simplify something is if it's a perfect square. So that's why we have this list over here that I just drew on. There we go. So with 12, I'm going to just start on these numbers. It doesn't matter that 2 divides into 12, because 2 is not a perfect square. It doesn't help me. It doesn't matter that 3 divides into 12, because 3 isn't a perfect square. It's not on this list. It doesn't help me. So I wouldn't bother with those. The things I'm looking for are 4, 9, 16, etc. So boom, straight to the 4. So 12 is the same thing as 4 times 3. That's exactly this form, something times something. When I have that, I can separate them. Square root 4, square root 3. Square root 4, hopefully that you're like, okay, that's why we're trying to find this perfect square. But this is it. Square root 4 makes 2. That's how I'm able to simplify that out. The 3, square root of 3 is nothing good, so that stays behind. It's not a perfect square. Let me get rid of this and just make up a couple more. Square root of 50. So I look at 50, 4 does not go in, 9 does not go in, 16 does not go in, 25 does go in. And again, lots of other things go into 50, but the only ones that count are the perfect squares. So 25 times 2. And once I have that, now I can think of it as square root 25 times square root 2. Square root 25 simplifies out of 5 out front, and then the 2 behind. And let me do that negative 27 now. So 27, 4 does not divide in, 9 does. Cool, so that would be the square root of negative square root of 9 times 3, or the negative of the square root of 9 times the square root of 3. And the negative of the square root of 9, the square root of 9 is 3, and that negative is just like a negative 1 out front that multiplies the 3 and makes it negative. And that's why I did want to start with that example, is because they both come out 3s, which makes it a little bit harder to follow. But hopefully those two help make sense of this. Let me know if you still have questions.